Long ago, another comet swung close by Jupiter. It too, like Shoemaker-Levy, had its orbit forever changed by the gravity of the giant planet. That comet was Halley. Today, it travels on a long elliptical orbit that carries it out beyond Neptune and back again for a spin around the Sun. Thanks to Jupiter, Halley is locked into a 76-year cycle. It last came our way in 1986. It's due back in 2061. Our understanding of comets began with Halley. More than any other, it's helped unlock the mystery of their origin. The story begins with the 17th century astronomer Edmund Halley. Until Halley's time, scientists thought that comets were only one-time visitors to our skies. They simply careened past Earth, never to return. But in 1680, Halley's friend, Isaac Newton, carefully observed the motion of a comet. He worked out that it was traveling in a closed orbit around the Sun. The deduction was part of his theory of gravity. Newton suggested that a comet with a small enough orbit might be seen again and again. To test the idea, Edmund Halley analyzed the sightings of 24 comets. Two important observations emerged. First, 3 of the sightings were separated by the same 76-year interval. Second, these same 3 comets seem to have virtually identical orbits. Could they be one and the same comet, a regular visitor? If so, the next return should be in 1758. Sure enough, on Christmas Day, 1758, long after Halley's death, the comet reappeared. They named it Halley's Comet. The revelation allowed astronomers to trace the comet back through time. One of these Chinese tomb drawings confirms Halley's appearance in the 2nd century BC. A coin struck in memory of Julius Caesar also bears an image of Halley. It had been seen in the emperor's youth. This, from 648, is what people called a broom star. It's the same comet. In 1301, the Italian painter Giotto made Halley's comet the Star of Bethlehem. Halley wasn't seen that first Christmas, but some astronomers have suggested another comet led the wise men on their journey. By Halley's appearance in 1910, the world of advertising had caught up with history's most famous comet. Scientists greeted the return of Halley with a new tool, photography. But the pictures lacked detail. The comet still withheld its secrets. Three-quarters of a century later, in 1985, Halley's comet was back. This time, super-sensitive cameras, giant telescopes, and a fleet of probes lay in wait. It was Halley's space-age debut, with pictures galore. Here, a head-on shot with spirals of comet gas trailing into space. By 1986, the best images were from the southern hemisphere. These, from Chile, after Halley had rounded the Sun. And this from the unpolluted skies of equatorial Africa, a fuzzy cloud called the coma, clearly visible as it shrouded the comet's nucleus. Curved tails of dust that appeared yellowish to the naked eye. and a straight tail of gas fluorescing blue over millions of miles. Another view from Africa. For the first time, scientists did more than merely observe the comet. They reached out to it. As Halley sped past, an armada of robot spacecraft raced to intercept it. 2 Soviet, 2 Japanese, and a European probe named Giotto. Giotto was going for the closest of close encounters. Scientists plan to fly Giotto directly through the inner coma of Halley's comet and record it on video. As Giotto homed in on its prey, computers purposely painted the comet in false colors. These allowed scientists unprecedented insight into the comet's brightness and density. But the pictures disappointed television viewers. "18 months later, supercomputers finally produced the view the public had expected, and few have seen until now. At the center, a peanut-shaped nucleus, a lump of primeval matter 6 miles by 9. Geysers of gas streamed at 20 tons a second, dust at 10. Through the fog, this was the very face of Halley. The video transmission was knocked out with fewer than 1,000 miles to go, but Giotto had unveiled a hard, darkened shell with an icy interior. From Earth, Halley put on its best show as it pulled away from the sun. Photographed over several months, the comet's tail lengthened and shortened day to day. Its overall brilliance fluctuated too. Astronomers attributed the variations to the solar wind, to changes in the composition of its surface, and to the rotation of the nucleus. From the deep chill beyond Neptune to its tour of the sun, Halley's surface had heated to over 200 degrees Fahrenheit. In the late 80s, as Halley receded, so its image faded. Then suddenly, in 1991, it brightened. Could the comet have collided with something? We'll find out in 2061. By February of 1994, Halley's comet was just a few specks on a photograph as it headed out past Saturn. The future will bring new comets. American and European astronomers propose actually landing on a comet. The craft will carry no astronauts. They would never survive. Instead, a powerful robot dart packed with sensors will do the job. Like a doctor's probe, the dart will take the first direct readings of a comet's temperature and chemistry. Then, via the mother craft, beam the data home. Comets, icy visitors from the depths of space. We have gazed at them in wonder, flown through their gossamer folds. Someday, we may actually touch these messengers from beyond the planets.